Hello there, and welcome back to Documentary for Sleep, where the world slows down and the mind is allowed to wander without anywhere it needs to be. Tonight, there is nothing for you to do, nowhere for you to go. You can let your shoulders drop, let your breathing settle, and let the sound of this voice carry you somewhere far away from the ordinary hours of your day. Tonight, we are going to travel downward, not across the surface of the earth, not into the sky, but down beneath the waves, into a darkness that covers most of our planet, and yet remains almost entirely unseen. We are going to look for mountains, not the mountains you know, the ones that rise into clouds and catch the morning light on their snowy peaks, but mountains hidden beneath the sea, mountains so tall that if you could lift them out of the water and set them on dry land, they would rise higher than Everest itself. It is a strange thought, isn't it? That the tallest mountain on Earth might not be the one we celebrate, the one climbers risk their lives to reach, the one whose name we learn as children. There may be a greater giant out there, standing quietly in the dark, its summit hidden beneath thousands of meters of cold, heavy water, and it has been standing there, patient and unbothered, for longer than any human story. Before we begin to drift down into that world, I wonder where you are right now. Perhaps you are lying in the dark, the room quiet around you, the day finally behind you. Perhaps it is raining softly outside, or perhaps the night is still and clear. Wherever you are, however your day has been, you have arrived here, in this small pocket of calm, and that is enough. There is no need to stay awake for any of this. If you fall asleep before we reach the bottom of the sea, that is perfectly fine. This journey will still be here, waiting, whenever you return. If you find these slow explorations soothing, you might gently consider subscribing or leaving a quiet like, so that others who are searching for rest can find their way here too, but only if it feels right. For now, there is nothing to ask of you except that you let yourself relax and let your imagination sink slowly beneath the surface of the sea. So let us begin. Close your eyes, if they are not already closed, and picture the ocean. Not the friendly shallows where light still dances on the sand, but the open ocean, far from any shore. Imagine standing on the deck of a ship in the middle of that vastness, the water stretching to every horizon, deep blue fading to gray where it meets the sky. Beneath you, the sea floor lies thousands of meters down, hidden in a darkness that no sunlight has ever touched. And somewhere down there, rising from that floor, are mountains. To understand why these hidden mountains matter, we first have to think about what we mean when we call something the tallest. It seems like a simple question. What is the tallest mountain on Earth? The answer most of us would give, almost without thinking, is Everest. And in one sense, that answer is correct. Everest's summit reaches higher above sea level than any other point on the planet, around 8,849 meters into the thin, cold air. Stand on top of it, and there is no solid ground anywhere on Earth that rises higher. That is a remarkable thing, and Everest deserves its fame. But notice the words we used. Higher above sea level. That little phrase hides a whole world of complication, because measuring a mountain from sea level is a choice, a convention, a way of agreeing on a starting line. And the sea is not the bottom of a mountain. It is simply the place where the water happens to sit. If we measured mountains a different way, from their true base to their true summit, the answer might change entirely. Imagine two people standing in a field, and you want to know who is taller. You would not measure one of them from the knees and the other from the ankles. You would measure each one from the soles of their feet to the top of their head. That is the fair way to compare them. But with mountains, we do something strange. We measure them all from the same line, the surface of the sea, even though their feet, the places where they truly begin, may lie far below that line or far above it. Everest, you see, has a head start. It does not rise from the bottom of the ocean. It rises from the Tibetan Plateau, a vast highland that is already more than 5,000 meters above sea level before Everest even begins. So when we say Everest is nearly 9,000 meters tall, we are measuring from the sea, not from the base of the mountain. The mountain itself, measured from the plateau it stands upon, is really only a few thousand meters of rock piled on top of an already enormous platform. It is the tallest point, yes, but it is standing on the shoulders of a giant landscape. Now imagine a different kind of mountain. Imagine one that begins at the very bottom of the ocean, on the deep sea floor, and rises up through all that water, breaking the surface and continuing into the sky. A mountain like that would have no head start. It would have to do all the climbing itself, from the deepest foundation to the highest peak. And if such a mountain rose 10,000 meters from base to summit, then by the fair way of measuring, by the way we would measure two people in a field, it would be taller than Everest. And here is the quiet secret of our planet. Such a mountain exists. In fact, several do. They are scattered across the Pacific, in a place where the Earth's heat rises up through the crust and builds volcanoes one drip at a time. We will visit one of them soon, the great white mountain called Mauna Kea. But before we do, simply let the idea settle in your mind, like sediment drifting slowly to the sea floor. The tallest mountain on Earth, measured honestly from foot to crown, is not the one we have been taught to admire. It is hidden, mostly, beneath the sea, and tonight we are going to find it. There is something gentle and humbling in this. It reminds us that the world is larger and stranger than the simple stories we tell about it. The records we keep, the rankings we make, the lists of tallest and deepest and longest, are human inventions, ways of organizing a planet that is far too vast to fully hold in the mind. The Earth does not know it has a tallest mountain. It does not care where the sea line falls. It simply builds and erodes and shifts, and the water settles wherever gravity pulls it, hiding some of its greatest works beneath a surface we cannot see through. So as you lie there, breathing slowly, let yourself loosen your grip on the things you thought you knew. Let the familiar facts soften and rearrange themselves. The world beneath the sea is not the world above it, and the rules are different there. Mountains can hide, giants can stand in darkness, and the tallest of them all has been waiting, quietly, for someone to come looking. Let us go to the Great White Mountain first. In the middle of the Pacific Ocean, far from any continent, there is a chain of islands we call Hawaii. They are small green dots on most maps, easy to overlook, surrounded by an immensity of blue. But those islands are deceiving. What you see above the water, the beaches and the rainforests and the gentle volcanic slopes, is only the very top of something enormous. Each Hawaiian island is the exposed summit of a mountain that begins far, far below, on the floor of the deep Pacific. And the greatest of these mountains is Mauna Kea. Its name means white mountain, for in the Hawaiian winters its summit gathers snow, a strange sight in the tropics, a cap of white floating high above a warm and gentle sea. From its base on the ocean floor to its snow-touched peak, Mauna Kea rises something close to 10,000 meters. Pause on that number for a moment. 10,000 meters. Everest, measured from sea level, reaches not quite 9,000, which means that Mauna Kea, measured the fair way, from foot to crown, is more than 1,000 meters taller than the mountain we call the highest on Earth. But you would never know it to look at the islands from a passing ship. Most of Mauna Kea is invisible. It hides beneath roughly 6,000 meters of ocean before it ever breaks the surface, and only its uppermost 4,000 meters or so stand in the open air. We see the head and shoulders of a giant and mistake them for the whole. The rest of the body descends into a darkness we rarely think about, down through layers of water that grow colder and heavier and blacker with every meter. Imagine, if you can, descending the flank of this mountain. You begin at the snowy summit, in the thin, clear air where the stars at night are so bright that the world's great telescopes have gathered there to watch them. The air is dry and cold, and the slopes are bare red rock, scattered with cinders. As you walk downward, the landscape softens. Grasses appear, then shrubs, then forests, the slopes growing greener and warmer as you go. You pass through the bands of climate that wrap around the mountain like rings, until at last you reach the shore, where the green land meets the blue water and the waves roll in. But the mountain does not end there. The shore is only the halfway point, or less. Beneath the waves, the slope continues downward into the water, and now you must imagine yourself sinking. The light fades quickly. Within a few tens of meters, the warm, bright blue of the shallows gives way to a deeper, dimmer blue. The colors begin to vanish, red first, then orange, then yellow, until everything around you is a soft and shadowy gray blue. You are still descending the same mountain, the same continuous slope of volcanic rock, but now the world has changed completely. Down and down you go. By a few hundred meters, the last of the sunlight is gone, and you enter what scientists call the twilight zone, where only the faintest gray glow filters down from above, too weak for any plant to live by. Deeper still, and even that fades to nothing. You are now in true darkness, the darkness of the deep ocean, where the only light is the light that living creatures make for themselves. And still the mountain descends beneath you, its slopes vast and silent, going down and down toward the abyssal plain, 6,000 meters below the surface. It is hard for the human mind to hold this picture, because we are creatures of the surface. We live in the thin, bright film at the top of the world, where the air is and the light is. The deep ocean is a place we almost never think about, and yet it is the largest living space on our planet by far. Most of the earth is ocean, and most of the ocean is deep, and most of the deep is dark and cold and crushingly heavy with the weight of all the water above. The mountains that rise through that world are some of the largest structures on the planet, and almost no human eye has ever seen them. Think about the pressure down there. At the surface, the air presses on you gently, a weight you have lived with your whole life and never noticed. But water is far heavier than air, and as you descend, the weight piles up. By the time you reach the base of Mauna Kea, 6,000 meters down, the pressure is hundreds of times greater than at the surface, enough to crush a submarine that was not built to withstand it, enough to compress the very air in your lungs to almost nothing. The deep ocean is not a gentle place. It is one of the most extreme environments on Earth, and the mountains there stand in conditions that would destroy almost anything from the world above. And yet they stand. Mauna Kea has stood for hundreds of thousands of years, and the deeper, older mountains around it for far longer. They were built slowly, by fire rising from within the earth, and they will be unmade slowly too, by the patient erosion of the sea, and the even more patient movements of the planet's surface. But for now, they remain, vast and quiet, holding up the small green islands we call home in the middle of the Pacific. There is something deeply restful in this thought, I think, that beneath the restless, glittering surface of the sea, where the waves never stop moving and the wind never stops blowing, there are these immense, motionless presences, mountains that do not care about the storms above them, mountains older than memory, deeper than light, taller than the highest peak we know, standing in perfect stillness in the dark. The world above may be busy and bright and full of noise, but the world below is calm and slow and ancient beyond imagining. As you lie there, you might let yourself feel a little of that calm, the stillness of the deep mountain, the way it simply is, without effort, without worry, without any need to be seen or counted or admired. It rises from the dark floor of the sea, and it holds its shape, and that is all it needs to do. There is a kind of peace in that, a peace that has nothing to do with us, that was here long before us and will remain long after. Let yourself rest in it, the way the islands rest upon the great hidden mountain that holds them up. We have looked at one mountain now, the great white mountain of the Pacific, but Mauna Kea is far from alone. The ocean floor is studded with mountains, thousands upon thousands of them, most of which have never been named, most of which no human will ever see. To understand how such a thing is possible, we have to understand how these mountains are made, and why so many of them are hidden. So let us drift now from this single giant to the whole crowded, mountainous world of the deep sea floor. Beneath the surface of the sea, the floor of the ocean is not the flat, featureless plain that many people imagine. For a long time, that is exactly what people did imagine. Before we had the tools to look, sailors and scientists alike pictured the deep sea bottom as a smooth, muddy expanse, dull and lifeless, sloping gently away into darkness. It was a reasonable guess, given that no one could see it, but it was wrong. The floor of the ocean is one of the most dramatic landscapes on Earth, ribbed with ridges and slashed with trenches, dotted with volcanoes, and covered, in places, with mountains beyond counting. These underwater mountains have a name. We call them seamounts. A seamount, in the simplest sense, is a mountain that rises from the seafloor but does not reach the surface, a peak that lives its entire life underwater, hidden from the world above. Some are small, gentle rises of a few hundred meters. Others are towering giants, kilometers tall, every bit as impressive as the mountains of the dry land, except that no one will ever stand upon their summits and look at the view, because their summits lie deep beneath the waves. How many seamounts are there? The honest answer is that we do not know. Not exactly, and the not knowing is part of what makes them so wonderful. Our maps of the ocean floor are still incomplete, still being filled in, and every new survey seems to reveal more of these mountains than we expected. But the estimates run into the tens of thousands of large seamounts, those over a kilometer tall, and likely into the hundreds of thousands, or even more if you count the smaller ones. The seafloor is, in truth, a crowded mountain range, a wilderness of peaks, almost all of them unexplored. Think about that for a moment as you rest. Hundreds of thousands of mountains, most of them never seen, never named, never visited. On land, we have named nearly every significant peak. We have climbed them, photographed them, written songs and stories about them. But beneath the sea, there are vastly more mountains than on all the continents combined, and the overwhelming majority of them are anonymous, known only as bumps on a map, if they are known at all. It is as though there were a second Earth hidden beneath the first, a whole planet's worth of mountains waiting in the dark. So where do all these mountains come from? Most seamounts, like the Great Mountains of Hawaii, are volcanoes. They are built by molten rock rising from deep within the earth, pushing up through the crust at the bottom of the sea and erupting onto the ocean floor. But an eruption underwater is a very different thing from an eruption on land. There are no great clouds of ash rising into the sky, no rivers of glowing lava flowing down a hillside in the open air. Instead, the lava meets the cold, heavy water of the deep, and something strange and quiet happens. Imagine molten rock, glowing orange and impossibly hot, oozing out of a crack in the sea floor. The instant it touches the frigid water, its surface chills and hardens, forming a skin, a crust, like the skin that forms on cooling soup. But the molten rock inside keeps pushing, and it breaks through the skin, and a new blob bulges out, and that too is chilled and hardened by the water. Over and over this happens, blob after blob, each one freezing almost as soon as it appears. The result is a strange, lumpy rock formation that scientists call pillow lava, because the rounded shapes really do look like a heap of pillows stacked upon one another, smooth and bulbous and gray. This is how the deep volcanoes build themselves, not in great dramatic outpourings, but in slow, quiet accumulations of pillow upon pillow, layer upon layer, over thousands and tens of thousands of years. The water muffles everything. The eruptions that build these mountains are often silent and invisible, happening in the dark far below, witnessed by no one. A mountain rises a meter, then another meter, then another, as the centuries pass, and the surface of the sea above it shows nothing, no sign at all of the slow and patient construction going on below. Some of these volcanic mountains grow tall enough to break the surface, and when they do, they become islands. The Hawaiian Islands were born this way, and so were many of the world's volcanic islands, from Iceland to the Galapagos to the countless small islands scattered across the Pacific. But most seamounts never reach that far. They grow for a while, building themselves up from the seafloor, and then the eruptions stop. The source of molten rock moves on or cools, and the mountain is left unfinished, its summit still hundreds or thousands of meters below the waves. And there it stays, a mountain that almost became an island, but never did, hidden forever beneath the sea. There is something poignant in that, I think. A mountain that reached upward, growing toward the light, and stopped just short. It will never feel the sun on its summit, never gather snow, never be climbed or named or celebrated. And yet it is no less a mountain for that. It stands just as tall, weighs just as much, shapes the waters around it just as powerfully as if it had broken the surface. It simply does its work in the dark, unseen, asking for nothing. Not all seamounts are born from hot spots in the middle of the ocean, the way Hawaii was. Some are born along the great cracks and seams where the Earth's crust is being pulled apart or pushed together. Some form in chains, marching across the sea floor in long lines. Some form in clusters, like fields of mountains. And some are so old that they have begun to crumble, their once sharp peaks worn down, their flanks softened by the slow rain of sediment that falls endlessly through the deep ocean, the dust of dead plankton and drifting particles settling, year after year, century after century, onto the mountains below. That sediment is worth pausing on, because it tells us something about time. In the deep ocean, far from any land, the floor receives a constant gentle snowfall of tiny particles, the remains of microscopic life that lived in the sunlit waters above, and then died and drifted down. This fall is unimaginably slow, perhaps a few millimeters every 1,000 years in the most remote places, and yet, over millions of years, it adds up, blanketing the seafloor and the lower slopes of the seamounts in a soft layer of mud, smoothing their shapes, burying their roots. An old seamount may be half buried in the sediment of ages, only its upper reaches still standing clear, the rest sinking slowly into the accumulated dust of deep time. When you think of these mountains, then, do not think of them as fixed and eternal, even though they stand so still. Think of them as slow. Everything about them happens on a timescale so vast that it makes a human lifetime seem like a single blink. They are built drip by drip, over tens of thousands of years. They are buried grain by grain over millions. They drift across the planet's surface, carried by the movement of the crust, at the speed your fingernails grow. To a seamount, 1,000 years is nothing, a moment, less than a moment. They live in a kind of time that we can barely imagine, a deep, patient, geological time, in which mountains are born and grow and die as slowly as the breathing of the earth itself. And so as you lie here, breathing slowly yourself, you might imagine the seamounts breathing too, in their own way, over their own vast spans of time, rising slowly, resting, sinking slowly back into the dark. There is no hurry in any of it. There never has been. The mountains of the deep sea have all the time in the world, and they spend it doing the only thing they know how to do, which is simply to be, quietly and enormously, in the dark. We have spoken of single mountains, of Mauna Kea standing tall, and of seamounts scattered across the deep. But the greatest mountain structure on Earth is not a single peak at all. It is a range, a chain of mountains so long that it wraps around the entire planet, winding through every ocean, and yet almost no one has ever seen it, because it too lies hidden beneath the sea. It is called the Mid-Ocean Ridge, and it is the longest mountain range in the world by an enormous margin. Consider the great mountain ranges of the land, the ones we know and admire, the Himalayas, the Andes, the Rockies, the Alps. Each of them is a few thousand kilometers long at most. They are vast by human standards, more than enough to fill a lifetime of exploration. But the mid-ocean ridge dwarfs them all. It runs for something like 65,000 kilometers, a continuous mountain chain longer than the circumference of the Earth, snaking down the middle of the Atlantic, curving around Africa, threading through the Indian Ocean, and crossing the vast Pacific. If you could somehow walk its length, you would travel more than 1.5 times around the world, and almost the entire journey would be in darkness, deep beneath the waves. This is the largest single geological feature on the surface of our planet, and for most of human history, we had no idea it existed. It was only in the 20th century, as ships began to map the seafloor with sound, sending pulses of sound waves down into the deep and listening for the echoes, that the shape of this great hidden range began to emerge. Slowly, survey by survey, a picture took form, and it was astonishing. A mountain range, continuous and immense, running down the center of the oceans like a seam stitched across the planet. And that word, seam, is closer to the truth than you might think. Because the mid-ocean ridge is not just a mountain range, it is a wound, or perhaps a birthplace. It is the line along which the Earth's surface is splitting apart, and new seafloor is being born. To understand it, we have to think about the great plates that make up the outer shell of our planet, the rigid slabs of rock that float upon the hotter, softer material beneath, and that drift slowly across the globe, carrying the continents and the ocean floors upon their backs. Along the mid-ocean ridge, two of these plates are pulling away from each other. As they separate, the gap between them does not become an empty chasm. Instead, molten rock rises up from below to fill it, welling up from deep within the earth, cooling and hardening into new crust. This new rock builds the ridge, a long mountainous welt running down the line of separation. And then, as the plates continue to pull apart, the new rock is carried away to either side, making room for still more to rise. In this way, the seafloor is constantly being created at the ridge and carried outward, like two great conveyor belts moving in opposite directions, endlessly, over millions of years. It is a slow process, far too slow for any human to watch, but it never stops. Every year, the plates move apart by a few centimeters, about the rate that your fingernails grow, and every year a fresh ribbon of new seafloor is added along the ridge. The rock at the very crest of the ridge is the youngest rock on the ocean floor, freshly made, still warm in places, and as you travel away from the ridge in either direction, the rock grows steadily older, having been made long ago and carried slowly outward over the ages. The oldest ocean floor lies farthest from the ridge, near the edges of the ocean basins, where it may finally plunge back down into the earth at the great trenches. But that is a story for later. Running along the very top of the ridge, in many places, there is a deep valley, a rift, a long crack where the splitting is most intense. If you could stand at the bottom of that rift valley, in the cold and the dark, you would be standing at the exact line where the planet is tearing itself apart and remaking itself, where two great pieces of the Earth's surface are slowly drifting away from one another, and the molten heart of the world is rising up to fill the space they leave behind. It is one of the most fundamental places on the planet, the very engine of the moving continents, and it lies hidden at the bottom of the sea, witnessed by almost no one. The scale of all this is difficult to hold in the mind, so let us soften it into an image. Imagine the Earth as a great round fruit, and imagine its skin slowly splitting along a seam that runs all the way around it. Out of that seam, fresh skin is forming, pushing the older skin gently aside. That is the mid-ocean ridge, the seam of the world, 65,000 kilometers of mountains rising along the line where the planet renews itself. And almost all of it is underwater, dark and cold and silent, the greatest mountain range on Earth, and one of the least visited places we know. In a few places, the ridge rises high enough to break the surface, and where it does, it makes islands. Iceland is one of these, a piece of the mid-Atlantic ridge that has grown tall enough to stand in the open air, which is why Iceland is a land of volcanoes and hot springs and cracking earth, a place where you can stand on dry ground and watch the very process that builds the ocean floor. But Iceland is the exception. For nearly its entire length, the great ridge stays hidden, doing its slow and patient work in the depths, building the floor of the sea one ribbon of rock at a time. There is a kind of comfort in knowing this is happening, even though we cannot see it. Right now, as you lie there resting, the planet is quietly remaking itself. New rock is rising along the great hidden ridge, deep beneath the waves, cooling into mountains, drifting slowly outward. It has been happening for hundreds of millions of years, and it will go on happening long after tonight, long after this voice has faded, long after every one of us is gone. The earth is always at work, always building, always renewing, in slow and silent ways, far below the surface of our notice. You do not have to do anything about it. You do not have to understand all of it, or remember it, or even stay awake for it. You can simply let it be there, this enormous, patient process unfolding in the dark, the seam of the world stitching itself together, 1 centimeter at a time. It will carry on without you. It always has. And there is a deep rest to be found in that, in knowing that the great works of the planet do not need our attention to continue, that they hum along quietly beneath us whether we watch or sleep, building mountains in the dark. Let us return now to Hawaii, and to the great white mountain we visited earlier, because there is more to its story, and it is one of the most beautiful tales the seafloor has to tell. Mauna Kea, you see, is not the only mountain of its kind. It is one of a long line, a chain of volcanoes and seamounts that stretches across the floor of the Pacific for thousands of kilometers, and the way that chain was made is a kind of slow, patient miracle. To understand it, imagine deep within the earth, far below the moving plates, a place where heat rises in a steady column, a plume of hot material welling up from the depths toward the surface. Scientists call such a thing a hot spot. It stays more or less in one place, anchored deep below, while above it, the great plate of the seafloor drifts slowly past, carried by the same forces that move the continents. The hot spot burns up through the plate like a candle flame held beneath a sheet of paper that is slowly being pulled across it, and wherever the flame touches, it builds a volcano. So picture the plate drifting, and the hot spot burning up through it. A volcano forms, grows tall, perhaps breaks the surface and becomes an island. But the plate keeps moving, and after a few million years, that volcano is carried away from the hot spot, off the flame, and its source of molten rock is cut off. It stops growing, it goes quiet, and meanwhile, behind it, over the hot spot, a new volcano begins to form, fed by the same rising heat. That new volcano grows tall, and then it too is carried away, and another forms behind it, and another, and another. In this way, over millions of years, the hot spot builds not one mountain, but a whole procession of them, a chain of volcanoes marching across the seafloor in the direction the plate is moving. The youngest sit over the hot spot, still active, still growing. The older ones trail away behind, growing more ancient the farther you go, slowly cooling, slowly sinking, slowly being worn away. The Hawaiian Islands are the young, active end of just such a chain. The big island of Hawaii, where Mauna Kea stands, sits nearly over the hot spot today, which is why it still has active volcanoes, but trail off to the northwest, island by island, and each one is older than the last, more worn, more sunken, until the islands give way to seamounts that have slipped entirely beneath the waves. And the chain does not stop there. It goes on, beneath the sea, for thousands of kilometers, a long line of drowned mountains marching across the Pacific. We call this trailing portion the Emperor Seamounts, and following them is like reading the history of the hotspot backward in time. The farther you go, the older the mountains, until at last, far to the north, near the edge of the Pacific, the oldest of them approach a great trench where the seafloor plunges back down into the earth, and there the most ancient mountains of the chain are slowly being swallowed, carried down and destroyed after 80 million years of drifting. But there is one detail in this story that is especially wonderful, and it is written into the shape of the chain itself. If you trace the line of these mountains across the seafloor, the Hawaiian Islands and seamounts, and then the Emperor Seamounts beyond them, you find that the line is not straight. It has a bend in it, a distinct kink, partway along, as though the chain were drawn by a hand that suddenly changed direction. For a long stretch, the mountains run one way, and then, quite sharply, the line turns and runs off in another direction entirely. What could cause such a thing? The mountains are made one after another by the same fixed hotspot, so the line they trace records the path the plate has taken as it drifted over that hotspot. And a bend in the line means that, at some point long ago, around 50 million years in the past, the direction of that drift changed. The Great Pacific Plate, carrying the future Hawaii upon it, was moving one way for tens of millions of years, and then, slowly, it shifted and began to move another way. The bend in the chain is the fossil record of that turning, a permanent mark left on the seafloor by a change in the deep motions of the planet, frozen now into a line of mountains, thousands of kilometers long. Think of what that means. By looking at the shape of a chain of underwater mountains, we can read the movements of the Earth's surface over tens of millions of years. We can see where the Great Plate was heading, and when it changed course, all written in stone and scattered across the floor of the sea. The mountains are a kind of clock and a kind of compass, recording the slow drift of the world. They do not know they are recording anything. They simply formed, one by one, wherever the hot spot happened to be. But taken together, they tell a story that no single mountain could tell, the story of a planet in slow and constant motion. There is a gentleness to imagining this. The plate does not move because anything pushes it suddenly. It drifts, slowly, over unimaginable spans of time, a few centimeters each year, carried by the deep churning of the Earth's interior. And as it drifts, it lays down mountains behind it like footprints, a trail of volcanoes stretching back across the ocean floor. Each mountain in that chain was once young and active, standing over the hot spot, perhaps an island green with life. Each one then grew old and quiet and sank away into the dark, while a new mountain rose to take its place. The chain is a kind of life story told in stone, birth and growth and old age and disappearance, repeated over and over for 80 million years. And the story is not finished. The hotspot is still burning, deep beneath the Pacific. New volcanoes are still being made. In fact, off the coast of the big island of Hawaii, beneath the waves, there is already a young seamount growing, the next in the chain, slowly building itself up from the sea floor. It is still far below the surface, and it will be tens of thousands of years before it breaks into the open air, if it ever does. But it is there, the newest member of the great procession, rising patiently in the dark, the future Hawaii waiting its turn. So when you picture the islands of Hawaii now, do not picture them as isolated dots in the sea. Picture them as the visible tip of an enormous, ancient, ongoing process, a chain of mountains, thousands of kilometers long, marching across the floor of the Pacific, recording the slow drift of the planet, the oldest of them being swallowed back into the earth, even as the newest of them is being born. It is one of the grandest and slowest stories on Earth, and it is unfolding right now, quietly, beneath a sea that shows nothing of it on its restless, glittering surface. Let that procession of mountains drift through your mind as you rest, one after another, rising and sinking, marching across the dark sea floor over millions of years. There is no rush in any of it. There never has been. The mountains take their time, all the time in the world, and they will keep marching long after this night is over. Among all the hidden mountains of the deep, there is one kind that carries a special mystery and a special sadness in its very shape. These are the flat-topped mountains, the seamounts whose summits are not pointed peaks but broad, level plateaus, as though some giant hand had reached down and sliced off the top of each one, leaving a smooth table standing in the dark. They were given the name Guyots, after a scientist who studied the Earth, and when they were first discovered, they were a genuine puzzle. How could a mountain in the deep sea have a flat top? What could possibly have planed it level, down there in the cold and the dark, far below the reach of any wave? The answer, when it came, was a story of rising and sinking, of islands that lived and died. And it goes like this. Imagine, once again, a volcano growing up from the sea floor, building itself drip by drip, until at last it breaks the surface and becomes an island, a fresh young island standing in the sun. Now the island is exposed to the open air and to the waves. And the waves are patient and relentless. Day after day, year after year, century after century, they beat against the shores of the island, wearing it down, grinding its rock to sand, eating away at its edges and its heights. Wind and rain join the work, carving the slopes, washing the soil into the sea. Over a long enough time, the waves and the weather can wear an island down almost to the level of the sea itself, planing off its peak, flattening its summit into a low, level platform barely above the water. The mountain that once rose high into the air is reduced to a flat stub, its top worn smooth by the endless labor of the waves. And then, the second part of the story begins. The sea floor on which the island sits is slowly sinking. Remember that the ocean floor cools and contracts and subsides as it ages and drifts away from the ridge where it was born. So the flattened island, riding on this slowly sinking floor, begins to descend. Down it goes, slowly, over millions of years. Its flat top, once just at the level of the sea, sinks beneath the waves. Deeper and deeper it sinks, until it is hundreds, then thousands of meters below the surface, far out of reach of any wave that could ever touch it again. And there it remains, a drowned island, a flat-topped mountain in the dark, its level summit a record of the long-vanished day when it stood at the surface and the waves wore it smooth. The flat top is a kind of memory, a frozen moment from the time when this mountain was an island in the sun, before it sank away into the deep. When you understand this, the flat-topped mountains become deeply moving. Each one was once an island, a piece of land standing in the open air, perhaps green with life, perhaps ringed with beaches and coral, alive with birds and growing things. And each one was slowly worn down by the patient sea, and then carried slowly downward, drowned, lost to the world of light. Now they stand in the cold, dark depths, level-topped and silent, the ghosts of islands that vanished millions of years ago. They are tombstones, in a way, marking the graves of lands that no longer exist, lands that the ocean reclaimed long before any human walked the earth. Around some of these drowned mountains, there is a further detail that adds to the wonder. When an island sits in warm tropical waters, corals often grow in a ring around its shores, in the shallow, sunlit water where they thrive. These corals build reefs, and the reefs grow upward as fast as the conditions allow. Now, when the island begins to sink, the corals face a choice, in a sense. If they can grow upward fast enough to keep pace with the sinking, staying always in the shallow, sunlit water they need, then they survive, building their reef ever higher, even as the land beneath them descends. The island itself drowns, but the ring of coral keeps growing up toward the light, and what is left behind is a ring of reef surrounding a lagoon where an island used to be. We call such a ring an atoll, and many of the world's beautiful coral atolls are exactly this, the living crowns of drowned mountains, coral reefs that kept growing upward as the islands beneath them sank away. This idea was first imagined long ago by a young naturalist sailing the world's oceans, and it turned out to be true. An atoll is the visible trace of a sinking mountain, a ring of life marking the place where a peak once stood. Beneath the coral and the lagoon, the drowned mountain descends into the dark, and the reef is its final, living memorial, the last part of it still reaching toward the sun. But even atolls do not last forever. If the sinking outpaces the coral's growth, or if the conditions change, the reef too may drown, and then the whole mountain, ring of coral and all, sinks away beneath the waves, becoming one more flat-topped guyotte in the deep. There is a slow rhythm to all of this, a rising and falling that plays out over millions of years. A mountain rises from the seafloor and becomes an island. The waves wear it down. The seafloor sinks, and the island drowns. Corals may crown it for a while, building atolls in the light, but eventually they too sink away, and the mountain becomes a flat-topped ghost in the dark, rising and falling, birth and growth and drowning, over and over, across the whole vast floor of the ocean, for as long as there have been seas. It is the breathing of the deep, the slow inhale and exhale of mountains, each one taking millions of years to rise and millions more to sink. To think of it this way is strangely peaceful. Nothing is permanent down there, and yet nothing is hurried. Every mountain has its time in the light, or near it, and then its long descent into the dark. There is no struggle in it, no resistance. The island does not fight the waves that wear it down, or cling to the surface as it sinks. It simply rises when it is its time to rise, and sinks when it is its time to sink, and in between it stands, for a while, in the sun, and then it lets go, and slips quietly into the deep, where it joins the countless other drowned mountains in their long, level-topped sleep. As you lie there, you might let yourself feel the gentleness of that long rhythm, the way the sea takes back what it gave, slowly, without violence, over spans of time so vast that the loss becomes something more like rest. The drowned mountains are not destroyed. They are simply somewhere else now, somewhere deeper, somewhere darker, lying still on the floor of the sea where the waves can no longer trouble them. They have done their rising, and now they do their resting, and they will rest there, flat-topped and silent, for longer than we can imagine, in the deep quiet of the world below the world. So far, we have spoken of the hidden mountains as if they were lifeless, great masses of rock standing alone in the dark. And in a way, the deep ocean does seem like a place where nothing could live, so cold, so black, so crushingly heavy. But this is one of the great surprises of the seafloor, and one of its quiet joys. The hidden mountains are not lifeless at all. Many of them are oases, gathering points for life in the vast emptiness of the deep, islands of abundance rising from the barren plains. To find a seamount in the deep ocean is often to find a garden. Why should this be so? Why should life cluster on the mountains rather than spreading evenly across the seafloor? The answer has to do with the way water moves. The deep ocean is not still. Great slow currents flow through it, rivers of water drifting through the darkness. And when these currents meet a seamount rising in their path, they cannot simply pass through it. They must flow around it and over it, and as they do, something important happens. The mountain forces the water upward, stirring it, mixing it, drawing up nutrients from the depths, and swirling them around the slopes and summit of the peak. Where there are nutrients, there is food, and where there is food, there is life. Picture the summit of a seamount, hundreds of meters below the surface, washed by these stirred and nutrient-rich currents. In the dim light of the twilight zone, or in total darkness deeper down, the rocky slopes are not bare. They are crusted with life. Corals grow here, but not the warm, shallow water corals you might picture from a tropical reef. These are deep-sea corals, cold water corals, strange and beautiful, growing slowly in the dark over hundreds and even thousands of years. They take the shape of delicate fans, of branching trees, of soft, feathery bushes, in colors of white and orange, and deep red and pink, glowing in the beam of a submersible's light, like a hidden forest no one knew was there. Among the corals grow sponges, some of them ancient, some shaped like vases or barrels or great glassy lattices, filtering the passing water for tiny particles of food. And among the corals and sponges live countless other creatures, sheltering in the branches, hunting along the rocks, drifting in the currents. Brittle stars curl their arms around the coral. Crabs and shrimp pick their way across the slopes. Strange fish hang in the water, waiting. The whole summit becomes a community, a dense gathering of life, clinging to the mountain in the middle of the empty deep, all of it fed by the nutrients that the mountain stirs up from the water flowing past. And the seamounts draw in larger life, too, from the open ocean. Because they concentrate food, they become gathering places, meeting points, oases that travelers seek out across the vast desert of the deep sea. Great schools of fish gather around them, swirling in glittering clouds. Sharks patrol their slopes. Sometimes the largest animals in the sea pass by, drawn to the abundance, the way travelers in a desert are drawn to a spring. A seamount can be a feeding ground, a breeding ground, a place of rest and plenty, in an ocean that is mostly empty. The mountains are not just landmarks in the dark. They are living centers, hubs around which the life of the deep ocean organizes itself. There is something lovely in imagining this. The deep ocean is, for the most part, a vast and thinly populated place, where life is spread very thin across enormous distances. To swim through the open deep is to pass through a darkness where you might travel for a long way and meet almost nothing. But scattered through that emptiness are the mountains, and each one is a beacon, a place where life has gathered and concentrated and flourished. If you could see the deep ocean lit up by all its living things, the open water would be dim and sparse, but the seamounts would glow like cities, bright points of abundance scattered across the dark floor of the world. These deep mountain gardens grow very slowly, and that slowness is part of their wonder and part of their fragility. A cold water coral may grow only a fraction of a millimeter in a year. A coral fan that stands a meter tall on a seamount slope may be hundreds or thousands of years old, older than many of the great works of human history, having grown patiently in the dark, current by current, year by year, since long before any of us were born. These are some of the oldest living things on the planet, and they live in some of the most remote and least visited places, growing quietly on mountains no human eye will ever directly see. Because they grow so slowly, these communities are precious, and they are easily harmed. A garden that took 1,000 years to grow can be undone in an afternoon, and there are real worries about the deep mountains and their forests of coral, worries about the heavy gear that is sometimes dragged across the sea floor, scraping away in moments what took millennia to build. But that is a concern for the waking world, and tonight we are letting the waking world soften and recede. For now, let us simply hold the image of the gardens themselves, flourishing in the dark, vast, slow forests of coral and sponge crowning the hidden peaks, alive with creatures we have barely begun to know. It is worth remembering how recently we learned any of this. For almost all of human history, no one knew these deep gardens existed. The bottom of the sea was assumed to be a cold, dead, muddy waste, and the idea that there were forests down there, ancient and teeming, would have seemed like a fantasy. It is only in the last handful of decades, as we developed the machines to descend into the deep and see, that the truth began to emerge. And every expedition still finds new things, new creatures, new gardens, new mountains crusted with life that no one had ever imagined. The deep mountains are still, in the truest sense, unexplored. We have seen only the smallest fraction of them. The rest wait in the dark, gardens that no one has ever visited, growing slowly, asking nothing, simply being beautiful where no eye can see. There is a profound restfulness in that thought, I think, beauty that needs no witness. Forests that grow in perfect darkness, on mountains at the bottom of the sea, simply because the conditions are right and life finds a way. They are not there for us. They were not made to be admired. They simply are, quietly flourishing in the deep, whether anyone ever comes to see them or not. And somehow that makes them more wonderful, not less. The world is full of beauty that has nothing to do with us, hidden in places we will never reach, and it goes on being beautiful regardless, patiently, in the dark. Let those deep gardens drift through your mind as you settle deeper into rest. The slow corals, the gathering fish, the silent slopes crusted with ancient life, all of it glowing softly in the imagination, all of it carrying on quietly at the bottom of the world while you lie here, safe and warm, drifting gently towards sleep. There is a stranger kind of life on the hidden mountains too, a kind that overturned almost everything we thought we knew about what living things need. To find it, we have to go to the places where the mountains are hottest, along the great ridge where new seafloor is being born, and along the flanks of the deep volcanoes, where the heat of the Earth's interior rises close to the seafloor. In these places, the cold, dark water meets the hidden fire of the planet, and something extraordinary happens. Seawater, you see, can seep down through cracks in the volcanic rock, sinking into the seafloor, toward the heat below. As it descends, it grows hotter and hotter, far hotter than boiling, though the immense pressure of the deep keeps it from turning to steam. Down in the cracks, this superheated water dissolves minerals out of the surrounding rock, becoming rich and laden with chemicals. And then, heated and buoyant, it rises again, surging back up through the seafloor and erupting into the cold ocean in plumes that look, for all the world, like smoke. These are the hydrothermal vents, and the first time anyone saw them, they could hardly believe it. Out of the seafloor, in the cold and the dark, rose chimneys of mineral rock, built up grain by grain as the hot water cooled and dropped its dissolved minerals. And from the tops of these chimneys billowed clouds of dark, shimmering water, hot enough to melt many materials, pouring out into the deep. They came to be called black smokers, for the dark plumes they release look like smoke pouring from a chimney, though it is not smoke at all, but mineral-rich water meeting the cold sea. Around them, the chimneys grow, sometimes to great heights, towers of rock built by the venting water itself, standing on the slopes of the hidden mountains. And here is the part that astonished the world. Around these vents, in the total darkness of the deep sea, far below any reach of sunlight, there is life. Not just a little life, but dense, thriving, abundant communities of strange creatures, crowded around the vents in numbers that rival the richest gardens of the surface. There are great tube worms, taller than a person, standing in clusters, their bodies white and their plumes a vivid red. There are pale crabs and ghostly shrimp swarming over the rocks. There are clams and mussels in dense beds, and fish drifting through the warm, shimmering water. A whole ecosystem, packed into the harsh and lightless deep, surrounding the vents like a garden surrounding a spring. How can this be? Every garden we know on the surface depends, in the end, on sunlight. Plants capture the light of the sun and turn it into food, and everything else eats the plants, or eats the things that eat the plants. Sunlight is the foundation of nearly all life we had ever known. But here, in the deep dark, there is no sunlight, and there never has been, and yet life flourishes. The discovery of these vent communities revealed something profound, that life can be built on a different foundation entirely. For at these vents, there are tiny living things, microbes, that do not need sunlight at all. Instead of capturing the energy of the sun, they capture the energy in the chemicals pouring out of the vents, the minerals dissolved in that superheated water from deep within the earth. They turn those chemicals into food, into the foundation of a food web, exactly as plants turn sunlight into food on the surface. And everything else in the vent community depends on them. The great tube worms, which have no mouths and no stomachs, are filled with these microbes, living inside their bodies, feeding them. The whole strange garden is built not on the energy of the sun, but on the energy of the earth's own interior, rising up through the hidden mountains and into the dark. This changed how we think about life itself. It meant that life does not strictly require sunlight, that it can be powered by the chemical energy of a planet's interior, in the deep dark places where no light ever reaches. And that, in turn, changed how we think about where life might exist beyond our own world. In the dark oceans that may lie beneath the ice of distant moons, oceans that never see the sun, but that might have their own hidden vents, their own warm chimneys rising from their own hidden sea floors. The discovery of life around the vents of our own deep mountains opened a door onto the whole universe of possibility. But that is a thought for another night. There is one particular place among these vent systems that deserves a moment of its own, because it is among the most beautiful and otherworldly places ever found on the floor of the sea. It lies on a great underwater mountain in the middle of the Atlantic, and it was given a name that captures its strangeness, the Lost City. It is not a city in any human sense, of course. It is a field of pale towers, spires of light-colored mineral rock rising from the slope of the mountain, some of them tens of meters tall, glowing ghostly white in the darkness when a light is shone upon them. They were built, like all vent chimneys, by water rising from within the mountain, but this water is gentler, warmer rather than scalding, and richer in different chemicals, And so the towers it builds are pale and tall and strangely graceful, like the spires of some drowned cathedral, standing silent in the deep. The lost city has been venting for a very long time, far longer than most vent systems, perhaps tens of thousands of years, and its quiet, pale towers have made it a place of deep fascination, because the chemistry happening within them may be similar to the chemistry that, long ago, on the early Earth, first gave rise to life. Some scientists wonder whether places like this, warm and mineral-rich and lightless, on the slopes of hidden mountains beneath an ancient sea, may have been the very cradle of living things, the place where the long story of life on Earth first began. If that is so, then we ourselves, and every living thing we have ever known, may trace our deepest origins to a hidden mountain at the bottom of the sea, to warm water rising in the dark, to pale towers standing silent in the deep. It is an astonishing thought to rest with, that the great chain of life, leading all the way up to you, lying there in the quiet of the night, may have begun on the flank of an underwater mountain, in total darkness, billions of years ago, that the first stirrings of life may have happened not in some sunlit pool, but in the deep, around the gentle warmth of a vent on a hidden peak. We are, perhaps, the distant children of the deep mountains, carried up at last into the light, but rooted, in our deepest origins, in the dark. You do not need to hold all of this. It is enough to let the images drift past, the black smokers pouring their dark plumes into the deep, the pale towers of the lost city glowing in the dark, the strange gardens of tube worms and ghostly crabs thriving where no light has ever fallen. Life finds a way, in the most unlikely places, on the slopes of mountains no one has ever seen. And maybe that is the most comforting thought of all, that even in the deepest dark, in the most extreme and hostile places, life takes hold and flourishes and endures. There is no darkness so deep that life cannot find its way into it. There is no place so hidden that wonder cannot grow there. So let the deep mountains glow softly in your mind, lit not by the sun, but by the patient fire of the earth itself, crowned with strange gardens, alive in the dark. And let yourself sink gently toward sleep, carried by the slow, warm currents of the deep, down past the gardens, down past the pale towers, into a rest as deep and quiet as the bottom of the sea. It may seem strange, in an age when we have mapped the surface of the moon and Mars, photographed distant galaxies, and built machines that can answer almost any question in an instant, that there should still be enormous mountains on our own planet that no one has ever seen, that we cannot even count properly. But it is true, and the reason is simple. We cannot see through water. The thing that makes the ocean so wonderful, that vast covering of water filling the great basins of the world, is the very thing that hides the seafloor from us. Light cannot pass through thousands of meters of water. Our eyes are useless in the deep. And so the floor of the sea, covering most of our planet, has remained one of the least known places in the entire solar system. Think about how we map the land. We can fly over it, photograph it, scan it from satellites in space, until we have a picture of nearly every hill and valley, every river and ridge, down to remarkable detail. We have done the same for the moon, for Mars, for worlds millions of kilometers away, because light travels freely through the emptiness of space and lets us see them. But the seafloor is wrapped in water, and water blocks our view as surely as a thick fog, except that this fog is kilometers deep and covers most of the world. To map the bottom of the sea, we cannot use light at all. We have had to find another way. The way we found is sound. Sound, unlike light, travels well through water, far and fast, which is why so many creatures of the sea use sound to find their way and speak to one another. And so, to map the seafloor, we send sound down into the deep. A ship sails across the surface, and from its hull it sends out pulses of sound, sharp clicks or pings that travel downward through the water. The sound reaches the seafloor, bounces off it, and returns to the surface as an echo, and the ship listens for that echo. By measuring how long the sound takes to travel down and back, the ship can work out how deep the floor is at that point, for sound travels at a known speed through the water, and the longer the echo takes to return, the deeper the floor must be. Ping by ping, echo by echo, a ship can trace the shape of the sea floor beneath it as it sails, building up a line of depth measurements, a thin ribbon of knowledge across the vastness of the ocean. Modern ships can send out many beams of sound at once, fanning out beneath the hull, so that they map a swath of seafloor as they go, rather than a single line. But even so, the work is painfully slow, because the ocean is so enormous, and the ships so few. A single ship, sailing for months, can map only a narrow strip of the immense ocean floor. To map all of it, in detail, this way, would take a vast fleet sailing for many years, and most of the ocean has simply never been crossed by a ship listening for echoes. And so, despite all our efforts, most of the seafloor has never been mapped in fine detail at all. We have a rough picture of its broad shapes, but a rough picture only, with most of its mountains and valleys unknown in their true form. There is a coarse global map of the ocean floor, but much of it was made not by ships at all, but by a clever trick using satellites, and it is worth understanding, because it reveals just how strange and indirect our knowledge of the hidden mountains really is. Here is the trick. A large mountain on the seafloor has mass, a great weight of rock, and that mass exerts a tiny extra pull of gravity on everything near it, including the water above. So a seamount, sitting on the seafloor, very slightly pulls the surrounding water toward itself, drawing the surface of the sea up into a low, broad mound directly above the hidden mountain. A mound far too gentle to see with the eye, only a few meters high spread over many kilometers, but real. And satellites in space, measuring the height of the sea surface with extraordinary precision, can detect these faint mounds and dimples. Where the sea surface bulges up slightly, there must be extra mass below, a mountain. Where it dips slightly, there must be a valley or a trench. From space, by reading the subtle shape of the sea surface, we can sense the shape of the hidden floor beneath. It is a remarkable thing to map mountains we cannot see by measuring the almost imperceptible way they pull the water above them. But it gives us only a blurry picture, enough to know that a mountain is there, and roughly how big, but not its true detailed shape. Many of the seamounts we know of are known only this way, as gravity bumps sensed from orbit, never directly observed, never visited, their summits and slopes and gardens entirely unseen. They are real, we are sure of that, but they remain shadows on a blurry map, hints of mountains rather than mountains fully known. There is now a great effort underway to change this, to map the entire seafloor in proper detail, ship by ship, beam by beam, pooling together the measurements of many nations and many vessels, so that one day we might have a true map of the bottom of the sea, as detailed as our maps of the land. It is a vast undertaking, and it is far from finished, and every year more of the hidden floor is brought into focus, more mountains revealed, more of the blur resolved into sharp detail. But there is a long way to go, and for now, the honest truth remains that we know the broad shape of distant planets better than we know the floor of our own ocean. This means that we live, all of us, on a planet that is still largely unexplored. Beneath the waves, in the dark, there are mountains we have never seen, valleys we have never traced, perhaps gardens and creatures we have never imagined, waiting in places no human has ever been. The age of exploration, which we sometimes think of as long over, the age when there were still blank spaces on the map, is not over at all. The largest blank space of all is right here, beneath the surface of the sea, covering most of our world, and we are only beginning to fill it in. There is something thrilling in that, and something deeply peaceful too. Thrilling, because it means the great adventure of discovery is not finished, that there are still mountains out there for someone to find, still wonders waiting in the dark. And peaceful, because it reminds us how much of the world simply carries on without us, beyond our knowledge, beyond our reach. The hidden mountains do not need to be mapped to exist. They were there long before we sent our first ship to listen for echoes, and they will be there long after. whether we ever finish the map or not. They stand in the dark, quietly, vast and unseen, keeping the secret of their true shapes to themselves. And as you lie there, drifting, you might let yourself enjoy that mystery rather than wishing it away. There is so much we do not know, so much we may never know, so many mountains we will never see, and that is all right. The not knowing is not a failure. It is a kind of spaciousness, a room left open, a reminder that the world is larger than our knowledge of it, and always will be. Let the unmapped depths be a comfort rather than a frustration. Out there, beneath the sea, in the great blank space of the map, the mountains are keeping their own quiet company, asking nothing of us, content to remain unknown. We began this journey with Mauna Kea, the great white mountain, taller from base to summit than Everest. But Mauna Kea, for all its height, is not the largest mountain hidden beneath the sea. Height is only one way to measure a mountain. There is also bulk, the sheer amount of rock, the breadth of the base, the total mass of the thing. And by that measure, by the measure of how much mountain there is, the deep sea holds giants that make even Mauna Kea seem modest. Consider Mauna Loa, Mauna Kea's neighbor in Hawaii, whose name means long mountain. It does not rise quite as high as Mauna Kea, but it is far more massive, a vast broad shield of a volcano, spreading out across the sea floor in gentle slopes that cover an enormous area. If you could measure the total amount of rock in Mauna Loa, from its deep foundations on the sea floor to its summit, it would dwarf the rock in any mountain on dry land. It is one of the largest volcanoes on the entire planet, a true giant, and most of it, like Mauna Kea, lies hidden beneath the waves, its broad base spreading far across the floor of the Pacific. But even Mauna Loa is not the largest. Out in the western Pacific, far from any land, beneath kilometers of water, there lies a structure so vast that when it was studied closely, it astonished the scientists who measured it. It is a single, ancient, enormous volcanic mountain, rounded and broad, built up long ago in the deep ocean, and its base spreads across an area so large that it rivals some of the great volcanic regions of other planets. It is among the largest single volcanic mountains known anywhere in our solar system, and yet you could sail directly over it and never know it was there, for its summit lies far beneath the surface, and the sea above shows nothing of the giant below. How can such enormous mountains hide so completely? It comes back, once again, to the water. On land, a mountain rises into the air, and the air is thin and clear, and the mountain stands out against the sky, visible for great distances, casting its shadow, catching the light. But a mountain in the deep sea rises into water, and water is dense and dark and deep, and it swallows the mountain whole. A peak that would dominate the horizon on land, that would be famous and admired and climbed, sits invisible beneath the sea, its grandeur entirely hidden, its scale known only to the instruments that probe the deep. The largest mountains on Earth, by sheer bulk, are precisely the ones that no one has ever seen, because the sea has hidden them so well. It is worth pausing to let the scale of these things settle in. We are used to thinking of the great mountains of the land as the largest features on Earth, the most imposing, the most permanent, and they are magnificent, but they are not the largest. The largest are below, in the dark, spread across the sea floor, broad and ancient and immense. If the oceans were somehow drained away, if all the water were lifted from the basins of the world, we would see a landscape that would astonish us, a planet covered in mountains far grander than the ones we know, ranges and peaks and vast volcanic shields stretching across what is now the sea floor, dwarfing the familiar mountains of the continents. The Earth we think we know, the Earth of land and visible mountains, is only the small dry top of a far more mountainous world. There is a humbling perspective in this. We build our sense of the world from what we can see, and what we can see is only a fraction of what is there. The great visible mountains, the ones in our photographs and our stories, are the exceptions, the few that happen to stand in the open air. The rule, the vast majority of the planet's mountains, lies hidden beneath the sea, unseen and unsung, larger and more numerous than anything on land. We have been admiring the small visible part of something far greater, like someone admiring the few branches of a tree that show above a wall, never knowing the whole forest that grows behind it. And these hidden giants are old, far older, many of them, than the mountains of the land. The great peaks we know on the continents, the high young ranges, are in geological terms relatively recent, still being pushed up, still sharp and dramatic because they have not yet had time to wear down. But many of the giant mountains of the seafloor were built long ago, in ages so distant that the continents themselves were arranged differently, the oceans shaped differently, the world a different place. They have stood through enormous spans of time, through the rise and fall of countless living things, through ice ages and warm ages, through the slow rearrangement of the entire surface of the planet. They are among the oldest standing structures on Earth, and they have kept their vigil in the dark through all of it, silent and patient, while the bright, busy world of the surface changed again and again above them. To imagine these ancient giants is to feel the depth of geological time pressing gently against the mind. A mountain that was already old when the first complex life crawled onto land. A mountain that stood in the deep while dinosaurs walked the continents, and while the dinosaurs vanished, and while the first small mammals crept into the spaces they left behind. A mountain that was there, unchanged, unhurried, while the entire human story, from the first stone tools to this very night, unfolded in a flicker too brief for the mountain to notice. The hidden giants live on a scale of time so vast that all of human history is less than an eye blink to them, and there is a strange peace in standing, for a moment, in the shadow of something so far beyond our small and hurried span. You do not have to feel small in a frightening way before these giants. You can feel small in a restful way, the way a child feels small and safe in the presence of something large and steady and kind. The hidden mountains are not threatening. They simply are, vast and ancient and calm, holding up the sea, keeping their slow vigil in the dark. They were here long before your worries, and they will be here long after them, and there is a comfort in that, in resting for a while against the great steadiness of things that do not hurry, and do not fret, and do not pass away in a single human lifetime. So let the giants stand quietly in your imagination, broad and ancient on the floor of the sea, larger than any mountain you have ever seen, older than almost anything on earth, asking nothing, needing nothing, simply being, in the deep, dark, patient calm of the world below. And let their steadiness become, for a little while, your steadiness too, as you settle deeper into the quiet of the night. Nothing on earth lasts forever, not even the great hidden mountains of the sea. They are born, they grow, they stand for ages, and then, slowly, they are unmade. We have already seen one way that a mountain can fade, worn down by the waves and drowned by the sinking floor, becoming a flat-topped ghost in the deep. But there is another ending, grander and more final, in which a mountain is not merely worn down or buried, but carried back into the earth and destroyed entirely, swallowed by the same planet that made it. Remember the great conveyor belts of the seafloor, the way new rock is born along the mid-ocean ridge and carried slowly outward to either side. That rock travels for millions of years, drifting away from its birthplace, growing older and colder and denser as it goes. And at the far edges of the ocean basins, the journey comes to an end. There, the old, cold, heavy seafloor reaches the boundary of another plate, and instead of crashing into it, it does something remarkable. It bends downward and dives beneath, plunging back into the depths of the earth, returning to the hot interior from which it came. This is the great recycling of the planet's surface, and the places where it happens are the deepest places in all the oceans, the great trenches. Now imagine a seamount, a hidden mountain, riding on this slowly moving seafloor. For tens of millions of years it has drifted along, carried away from wherever it was born, traveling across the ocean at the pace of growing fingernails. And now, at last, it approaches the trench, the place where its plate dives down into the earth. The mountain, riding on the descending floor, is carried toward the edge, toward the great downward bend, toward the point of no return. And there, slowly, inexorably, it begins to descend. The mountain that rose from the sea floor so long ago is carried back down into the planet, scraped and broken at the trench, dragged into the depths, melted at last in the heat below. This is the fate of the oldest mountains of the great chains, the ones at the far ends, the most ancient of all. We saw it with the Emperor seamounts, the oldest mountains of the Hawaiian chain, drifting north for 80 million years until the most ancient of them reached a great trench and began to be swallowed. One by one, over the ages, the oldest mountains of the chain reach the trench and descend, returning to the earth, while at the other end of the chain, new mountains are still being born over the hotspot. The chain is, in this way, a slow river of mountains, flowing from birth at one end to destruction at the other, each mountain making the long journey across the seafloor, only to be carried down at last into the deep. There is no tragedy in this, only the great turning of the planet. The rock that made the mountain is not lost. It returns to the interior of the earth, where in time it may rise again, melted and reformed, to build new mountains in new ages. The atoms that once stood as a peak in the sun may one day stand as a peak again, somewhere else, in some far distant future, when everything we know is long forgotten. The earth does not waste anything. It builds and unmakes and rebuilds endlessly, recycling the very stone of the world over spans of time so vast that the rise and fall of a mountain is, to the planet, like the rise and fall of a single breath. It helps, I think, to see the hidden mountains this way, not as fixed and permanent things, but as moments in a great slow flow. Each mountain is a gathering of rock that rose and stood for a while, and will in time be carried back down and dispersed, only to gather again somewhere else. They are more like waves than like statues, slow waves rolling through the stone of the planet over millions of years, rising and cresting and falling and rising again. We catch them in the middle of their long lives, standing tall in the dark, and we think of them as solid and eternal, but they are passing through, like everything else, in their own unimaginably slow way. And the same is true of us, and of everything. The matter that makes us was forged long ago in stars, and gathered into the earth, and cycled through countless living and non-living forms before it became us, and will scatter again when we are gone, to be gathered into other forms in turn. We are gatherings, like the mountains, brief patterns in the long flow of matter through the universe. The mountains rise and fall over millions of years, and we rise and fall over a handful of decades, but the difference is only one of speed. We are all passing through. We are all part of the same great turning. There is a deep and gentle comfort in this, if you let yourself feel it. The fear of endings, the fear of things passing away, softens when you see that nothing is truly lost, that everything is part of a great cycle of gathering and dispersing and gathering again. The mountain that is carried down into the earth is not destroyed. It is changed and returned and will rise again. And in the same way, the things we hold and the moments we cherish are part of a flow far larger than ourselves, a flow that does not end, but only changes form, endlessly, patiently, across spans of time too vast to fear. So as the old mountains drift toward their trenches in the dark, and bend, and descend, and return to the deep heart of the earth, you might let any tightness in you descend and soften too. There is nothing to hold on to, and nothing that needs holding. Everything is moving, slowly, gently, through its long cycle, the mountains and the seafloor, and the very stone of the planet, and you, along with all of it, carried on the same great patient current toward rest. You do not have to resist it. You can let go, the way the old mountain lets go at the edge of the trench, and sink quietly into the deep, trusting the long, slow turning of things to carry you where you need to go. It would be easy to think of the hidden mountains as separate from us, remote and irrelevant, sealed away in a deep, dark world that has nothing to do with the bright surface where we live. But this is not true. The mountains beneath the sea shape the world above in ways that reach all the way up to the air we breathe and the weather over our heads, and even, in the end, to the food on our tables and the comfort of our lives. They are not apart from us. They are part of the great connected machinery of the planet, and quietly, from the deep, they help to make the world habitable. We have already seen how the mountains stir the deep currents, forcing the slow rivers of the ocean to rise and swirl as they flow around the peaks, drawing nutrients up from below. This stirring does not only feed the gardens on the mountains themselves, it reaches far beyond them. The nutrients lifted toward the surface near seamounts can feed great blooms of tiny floating life in the sunlit waters above, the microscopic drifting plants of the sea, and those tiny plants are the foundation of nearly all life in the ocean. They feed the small creatures that drift in the water, which feed the fish, which feed the larger fish, and the seabirds, and the whales, and, in the end, us. The mountains, by stirring the deep, help to fertilize the sea, and a fertile sea is a sea full of life. Those same drifting plants of the sea do something else too, something that touches every breath you take. Like all plants, they draw in the carbon that floats in the air and the water, and they release the oxygen that we and nearly every creature need to live. A great share of the oxygen in the world's atmosphere comes not from the forests of the land, as we often imagine, but from these tiny floating plants of the sea, growing in waters that the deep mountains help to feed. And in drawing down carbon, they help to regulate the temperature of the whole planet, pulling carbon out of the air, and, when they die and sink, carrying it down into the deep, where it can be locked away for ages. The hidden mountains, by stirring the waters that feed this vast invisible garden, are part of the planet's slow breathing, part of what keeps the air fit to breathe and the climate steady enough for life. The mountains shape the great currents in larger ways too. The ocean is crossed by enormous flows of water, vast slow rivers that carry heat from the warm parts of the world to the cold parts, and cold water back again, moving warmth around the planet and softening the extremes of climate. These great flows do not move freely. They are guided, channeled, deflected by the shape of the seafloor, by the ridges and the mountains and the deep basins. A hidden ridge can block a current, or turn it, or split it. A great underwater range can force the flow of water along its length, steering the rivers of the sea. The pattern of warmth and cold across the whole surface of the planet, the climates of distant coasts, the gentleness or harshness of far-off lands, all depend in part on how the water moves, and how the water moves depends in part on the hidden mountains it must flow around. The shape of the deep, dark, unseen floor of the sea helps to set the weather of the bright and living world above. There are gentler gifts as well. The mountains and ridges of the seafloor can shelter coasts, breaking the force of the deep ocean before it reaches the shore. They provide the foundations on which islands grow, the islands where so much life has flourished and where so many people have made their homes. The very ground that many island peoples stand upon is the summit of a hidden mountain, the top of a giant that rose from the deep and broke the surface long ago. When you stand on a volcanic island, on Hawaii or Iceland or any of 1,000 others, you are standing on the peak of one of these mountains, on the small, dry crown of something enormous and hidden, your feet resting on the very top of a tower that descends for kilometers into the dark. And the mountains hold records too, archives of the planet's history written in their rock and in the sediment piled upon them, in the layers that settle on the seafloor and on the lower slopes of the seamounts. The story of the Earth's past is preserved, the changing chemistry of the oceans, the comings and goings of ancient life, the great events that shaped the world. The remains of countless tiny creatures, falling endlessly to the deep over millions of years, build up a record that scientists can read, learning the temperatures of ancient seas, the rhythms of ancient climates, the long, slow story of the planet. The hidden mountains and the deep floor around them are a library, vast and quiet, holding the memory of the Earth in their patient layers, waiting for anyone who learns to read them. So the hidden mountains are not separate from the living world at all. They feed it and shelter it and help to steer its climate and hold its history. From the deep dark, unseen and unthanked, they do their quiet work, and the bright busy world above goes on, never knowing how much it owes to the silent giants below. The fish that feed the coasts, the oxygen in the air, the warmth carried to distant shores, the islands where life thrives, all of it connected in ways we are only beginning to understand, to the mountains hidden beneath the sea. There is something deeply reassuring in this web of connection. Nothing in the world stands truly alone. The deepest, darkest, most remote places are bound to the brightest and most familiar by countless invisible threads, and the whole vast system hums along together, each part supporting the others, the hidden holding up the scene. You, lying there in the warm dark, breathing slowly, are connected by those threads to the mountains at the bottom of the sea, to the stirring of the deep currents, to the tiny floating plants in the sunlit waters, to the slow breathing of the whole living planet. You are part of it, held within it, carried along by it, as much as any island resting on its hidden peak. And you do not have to do anything to be part of it. You do not have to earn your place in the great connected world, or prove yourself worthy of it, or even understand it. You are simply part of it, woven in, held, the way the island is held by its mountain, and the mountain by the floor of the sea, and the sea by the great round body of the earth. Let yourself feel held, for a little while, by all of it, by the whole vast, gentle system of the world, the hidden mountains and the moving waters and the breathing planet, all of it carrying you, asking nothing, holding you up in the dark. We have traveled a long way tonight, down from the bright surface of the sea, through the fading light and into the dark, along the slopes of the great white mountain, across the crowded floor of the deep, past the long chains of drifting peaks and the drowned flat-topped ghosts of vanished islands, through the gardens of slow coral and the strange warm cities of the vents, down to the oldest giants and the trenches where mountains return to the earth. We have wandered through a whole hidden world, a world that lies beneath the one we know, larger and older and stranger than the surface ever lets us see. And perhaps the deepest thing we have found is not any single mountain, but the simple, quiet fact of all this hidden grandeur. Most of our planet is ocean, and most of the ocean is deep, and the deep is full of mountains, the greatest and most numerous mountains on Earth, and almost none of them have ever been seen. We live on the small, bright top of a vast, dark world, and beneath us, always, in the cold and the silence, the hidden mountains stand. They were there before us. They will be there after us. They do not need us to see them, or name them, or admire them. They simply are, quietly, enormously, in the dark. There is a kind of peace that comes from knowing this, a peace that has nothing to do with achievement, or understanding, or being noticed. The hidden mountains achieve nothing, in our sense. They are not trying to be the tallest, or the largest, or the most important. They are not competing, or worrying, or striving. They simply rose, when it was their time to rise, and they stand, for as long as it is their time to stand, and one day they will sink or be swallowed, when it is their time for that, and none of it troubles them at all. They rest in being exactly what they are, and there is a deep and ancient calm in that, a calm we can borrow, for a little while, on a quiet night like this one. You do not have to be seen to be real. You do not have to be measured, or ranked, or admired to matter. The tallest mountain on Earth stood unseen and unmeasured for hundreds of thousands of years, and it was no less magnificent for that. It did not need anyone to climb it, or name it, or put it on a list. It was complete in itself, whole and vast and quiet in the dark. And so are you, in your own way, complete in yourself, whole and real. Whether or not the world ever fully sees you, you can let go, tonight, of the need to be noticed, and simply rest, the way the great mountain rests, in the deep quiet of being exactly what you are. And when you go out into the world again, after this night and this rest, Perhaps you will carry a little of the hidden mountains with you. Perhaps, when you stand by the sea, you will remember what lies beneath it, the vast, dark, mountainous world hidden under the glittering surface, the giants standing silent in the deep. Perhaps you will feel, just for a moment, the strange comfort of all that hidden grandeur, all that beauty that asks nothing of you, all that ancient calm carrying on far below the surface of things. The world is so much larger and stranger and more wonderful than it usually seems, and most of its wonders are quiet and hidden and patient, waiting in places we will never go. But that is for later. For now, there is nothing to do but rest. The journey is over, or nearly so, and you can let it all drift away. The mountains and the currents and the dark deep sea, soft and fading now, like a dream you are already half inside. There is nothing left to follow, nothing left to picture, nothing left to hold. You can let the images dissolve, gently, into the quiet, and let yourself sink the rest of the way down, into a sleep as deep and calm and untroubled as the floor of the sea. If this slow journey has brought you some peace tonight, you might consider staying with us for more wanderings through the hidden corners of the earth, more quiet explorations of the slow and wonderful world. A gentle like or a subscribe helps others who are looking for rest to find their way here too, to this calm little corner where science unfolds slowly and the mind is allowed to wander toward sleep, but only if it feels right to you, and only in the waking hours. For now, there is nothing to ask of you at all. So let your breathing slow. Let your thoughts grow soft and quiet. Let the last images of the deep mountains fade gently into the dark. They will keep standing there, far below the waves, all through the night, all through your sleep, all through the long, slow turning of the world, exactly as they have for ages beyond counting. They do not need you to watch over them. You can rest now, fully, completely, held by the great steady calm of the hidden world below. Thank you for spending this quiet time here, drifting down into the deep with me. May your sleep be as deep as the ocean, and as calm, and as untroubled. And may you carry a little of the stillness of the hidden mountains with you, down into your dreams, and up into whatever gentle morning waits on the far side of the night. Rest well, sleep deeply, and we will wander together again, some other quiet night, through some other hidden corner of this strange and beautiful world. Good night.